My name is Carlos Villavicencio, and we'll talk about Apache Spot. It's an open source project. So let me start. If you have questions, just raise your hand and interrupt me. It's not a big deal. Okay. Well, who I am, as I mentioned, I work for Intel. I'm security researcher. I work in data center group. I'm not part of the Intel security side, so I need to do this because most of the time people think that I work for McAfee Intel security, but I work for the data center group. Okay. So this is the agenda, next generation security analytics. We will explain about Apache Spot incubating project that we are working in DCG. I will show you a demo of the graphic user interface that we are developed and the architecture behind Apache Spot, our roadmap, and the question and answers time. So we have this billion of events each day in our data centers, right? Most of the time we try to collect these particular logs, as the guy from a couple of sessions ago mentioned. We have trillions of events in our data center, right? So how can we manage that? So we start to thinking inside of Intel and with another partners, how can we do this? We require a scale, as you may see on the foil, big data analytics, and also include machine learning in order to detect that particular things that are not visible for the SAMs, for the other tools that is, well, working with signatures. So basically, this is pretty much how a Spot offers to you guys. So this is the next generation security tool. Basically, as you may see on the foil, SAMs manage terabytes per day. Well, correlating, logging, and staging different sources, firewalls, IPS, syslogs, whatever you need, right? Most of the SAM have different connectors in order to, well, store that information. You can analyze it, basically. But using big data, well, gives you the next layer. You can store petabytes per day, ingest this particular information in a cluster using HDFS or another technology. In order to, you can query this information, manipulate, generate scripts, do whatever you want, right? So, and that is pretty much the philosophy behind Apache Spot. You can check it. We, as Intel, donate the code a couple of months ago to the Apache Incubator project in order to, well, basically everybody can use this particular project in order to ingest whatever information that you need. I saw a couple of talks yesterday that, well, basically you need to store different layers of information, correlate the information there, make mixes, well, basically do whatever you want on top of Apache Spot. So, as I mentioned, this is Apache Spot. I will do a demo of the GUI, as I mentioned before. I'm running Docker containers on this Windows machine, and I basically download the code that we have available on the Apache Spot project. It's a container. You just download the container, and you can see. Let me move this one. Sure. Let me just the presentation. Okay. So this is the graphical user interface that Apache Spot will offer to you guys. As you may see, this is the result from one day ingesting net flows in our corporate environment. We ingest 10 billions of events each day. And this is the results that we obtain using machine learning algorithms. I will describe this part later. This is just to show you how the GUI of a Spot looks like. Basically, on the top, we have something that we call suspicious results. The suspicious results basically is the result of our LDA algorithm that analyzed these 10 billions of events. Well, this is the results of 1 day of our NetFlow infrastructure, right? Basically, we collect this information, we send it to the cluster, we analyze it, and we present this to the customer, right? I will just show a couple of information that we, well, basically find and looks interesting for us. So, well, the IP address was changed because we can share our internal subnets. But anyway, this is the result. As you may see, we have ranks. This is more suspicious for the algorithm. And we also add information or context to these particular NetFlow connections in order to you can, well, go in these particular results and start to looking at this kind of connection, right? We are using geolocalization in order to, well, display what is the location of this particular connection that you are seeing inside of your network. We also use threat intelligence feeds. In this case, we are using GTI, but you can use whatever vendor you have internally in order to add a context, right? Yesterday, as I mentioned before, I listened that a couple of guys needs to do this kind of hunting, right? Have results and add context using different sources, right? That is the philosophy behind Apache Spot. If you have a data source and you want to add context and you have the other data in different sources, you can mix it here and, well, basically use a machine learning algorithm in order to select the results that are interesting for your network, right? So this is pretty much the interface where we display the results for the community. We have also a network view in order to you can use it to check what is the patterns inside of your network, right? If you see something that is not normal in your organization, you can just select it and go in deep to that particular communications, right? So I don't know if you can see it. Yeah, well, as you may see, as soon as you tooltip that particular information, Spot will tell you the IP address. And if you want to filter, yeah, you just click and you can isolate that particular information and display it over here. If you can check the details of that particular NetFlow information, you can do it. It's not a big deal. The other part of the product is something that we call notebooks. The notebook basically is IPython code that you can use in order to query the data. In this case, we modify the view because most of our customers or most of our guys from the community are guys that are interested on security, not too much on develop IPython scripts. So if you are a data scientist, you have IPython code here in order to you can query the data that you have on the cluster, right? And do different analysis. So let me go back. And basically, the important part here is that that particular results that Apache Spot generates, you can basically score it and give this particular feedback to the machine learning in order to the next day they don't show you these particular results again. If you score this as a 3, this means that this is not important for your organization. So the next day the machine learning just, well, avoid that particular results and will start to show you interesting stuff like the stuff that I'm displaying here. And also if you can start to generate threat hunting or, well, indicate that this is maybe an attack inside of your organization, you can rate this particular connection as a 1, score it, and basically the model of threat intelligence of the Apache Spot will generate this information. And we want to share with you this particular rating. In our roadmap, we will share this information with other sources in order to you can react properly. So basically, this is our main use case, collect NetFlow and represent this information on our GUI. However, as soon as we start to develop this, some of the guys out there tell us that would be really interesting if we can ingest different sources. So we start to develop another use cases like a DNS. Basically is the same philosophy, just using another data source. In this case is, as I already mentioned, DNS. You can do the same stuff, right? As soon as you collect your millions or billions of DNS logs on the cluster, the machine learning algorithm will just display you the 220 suspicious connects for DNS, and you can start the hunting from here. As you may see, is the similar approach, just with a different data source, right? Okay. You can also rate the DNS connections and start to catching DNS, command and controls over DNS, tunnels, different attacks that you can discover, and well, also the bad guys can use in order to exfiltrate information using this particular protocol. Our next use case that we are developed and we are finishing right now is proxy. We are ingesting proxy logs in the Apache Spot platform in order to do similar stuff as a NetFlow and DNS, right? So this is pretty much the graphical user interface of Apache Spot. If you can use it and play with it, with this is a Docker container. You just pull it and see the information, right? But let me return to the presentation. So this is pretty much the architecture that we are managing behind the scenes on Apache Spot. As you may see, we have data sources, different data sources on Apache Spot. We have NetFlow that comes from routers and switches. We have DNS that a couple of these logs comes from Bro, and a couple of logs for the DNS comes from Windows also. We basically have collectors. These particular collectors, let me check. How can I? Okay. These particular collectors basically are daemons running in Linux that ingest the information to our file system. In this case, it's HDFS. We are using Cloudera in order to basically storage this information. And after that, right now we are using Spark in order to analyze all these results and generate the information that I showed you previously, right? So this is pretty much the information, the architecture behind the scenes, and we also are using the GUI that I described a couple of minutes ago. And this is based on Cloudera, but you can use Hadoop or whatever other technology that you want, MapR or any other technology that supports HDFS, you can use it. Basically, we are just developing, obviously, the collectors. How can we process the data stories? Just HDFS, and we are using Spark, right? Previously, we are using MPIs in order to analyze and generate the suspicious results, but right now the code is just in Spark. Right? And well, we have on the roadmap another integration with different Intel security products. We will show you this in a couple of weeks. And that is pretty much all. This is the architecture behind the scenes for the Apache Spot project. As I mentioned, we are using LDA in order to detect and generate these suspicious connects. Okay, this is another part of the architecture of Apache Spot. As you may see, we can collect information from the CM also. If you have a CM and you can ingest this particular information on Apache Spot, you can do it. We have 3 connectors right now, but we are working in order to develop another connectors, like as you may see down. Another use cases that we want to develop is endpoint, give more user context. This means that we want to, well, basically go to whatever authentication source that you have and basically write this information in order to, as soon as you have the suspicious results, you may know which machine is doing that particular traffic and which user is logging in that particular machine, right? So we are having also another initiatives. That is another one that is very interesting is this one, open data models. Open data models would be a huge table where you can basically write whatever you want, no matter if it's a use case from DNS, proxy, IPS, firewall, raw data, whatever. You can basically write the information there and add context on top of this particular raw data in order to the Apache Spot GUI can give you more information as soon as you have it on the graphical user interface. Well, a couple of hours ago, well, basically, the guy from Atalashian mentioned that they are using Kafka on Amazon. We are also trying to do this in order to ingest faster the information that we are collecting on the cluster. So that would be our next step, use Kafka and Apache Stream, Apache Stream, in order to write faster and replicate information in the HDFS side and for whatever other source that we needed, right? And as I mentioned before, right now this part is already working. We changed the machine learning code to run on Spark, and this gives us more response time. Before we are taking like 8 hours in order to analyze 10 billions of events. Right now we are taking just 3 hours in order to analyze 10 billions of events. This is net flow. This is just net flow. We are analyzing another kind of sources like DNS and proxy, but we need to measure how many time we will consume in order to generate the suspicious results. So this is a current effort. So this is how Apache Spot delivers to you. As I mentioned, data and analytics platform, open data model. We will show this particular sub-project in a couple of weeks in RSA. So if you want to contribute to the open data model, you are welcome, because we need a lot of expertise on the security side. So I see that you have a lot of ideas related with this, and if you want to contribute, this is an open source project based on the Apache Foundation, so you are welcome. Let me go back. Oops. So, well, in this case, we are very tied to the cybersecurity use cases. So like threat hunting, incident detection and resolution, a lot of things that you previously mentioned in other speeches and also in face-to-face meetings that I have yesterday with some of you guys. We are offering this to you. However, we have another use cases in the financial institutions, also in medical institutions, that they are not using Spot as cybersecurity tool. They are using Spot in order to detect fraud and things that are not common inside of the organizations. So we are just trying to share the Apache Spot idea with you for the cybersecurity side. However, we can use this particular tool in other use cases not tied to cybersecurity. Okay. So this is our roadmap and the ideas that we have right now in mind. Also, if you want to see another kind of information on Apache Spot, or you need another features on the tool, you can send us emails and we can prioritize this, because this is right now this is a project of the Apache community, right? So if you subscribe to the community, you can send ideas or request enhancements in order to, well, basically enhance the product. So on the top you will see, and you can read that we need to enhance the machine learning algorithms. Basically right now we are using just one LDA in order to detect, but we know that just one algorithms will not detect everything. So we are trying to enhance that particular pillar on the Spot product. The second one is, as you already see, we need more collectors in order to ingest different data in the Apache Spot and correlate this particular information inside of the product in order to provide the incident response phase to our community. We have also, well, we require, some of our customers request root cause analysis that involves that we need to, well, integrate with other third-party tools in order to do forensic analysis, collect logs from sources that we are not collecting right now. So we are working on that also. As you may see on the left side, wider scope of analysis means that we need to integrate more and more data, no matter if it's structured or unstructured. So we are working in order to provide that to you guys. And as I mentioned before, the other huge topic that we have right now is open data model. We are creating this particular model in order to, well, basically give a robust platform in order to you can collect whatever information you want and correlate the information inside of Apache. The idea is that you don't need to go to other sources in order to find that particular information. And well, this is pretty much all. Get involved with us. As you may see, we have different areas of the project, collectors, machine learning. We have also the graphical user interface, and well, the develop of the open data model. If you want to, well, share with us your knowledge, develop or give us ideas, you can contact us. You can go to the Slack channel or tweet us. And that is pretty much all, guys. I don't know if you have questions. This is a couple of guys that are working on this particular project. Just Cybraya, Centrify, eBay, Cloudweek, well, obviously Cloudera. And well, if you want to share and be part of the Apache Spot community, just contact us. So, questions? Right now. Shoot.
For your example you had earlier with NetFlow, going through to determine what's a, I don't think you use the word threatening and non-threatening, but you know the 3-2-1 scale. That seems like going through by hand is going to be extremely tedious, and for corporations the size of people who are in this room will be impossible.
Right.
So on average, like how many decisions like that would you really need to start seeing hostile stream rise to the top of your suspicious file?
Well, the first, I say 2 weeks, we start just to train the algorithm, just saying to the machine learning algorithm that this is not important for me, and just save it, right? After this particular 2 weeks, I start to see this kind of information where I can detect things that are not common in my organization. So I just need to train a couple of days the algorithm in order to start to seeing results, right? I see results from the first day, but maybe most of the results will be, let me remove the filter, please. Will be not valuable, right? But after 2 weeks, I will see a really cool suspicious results in order to start the hunting, right? So it's very useful because, well, as you already mentioned, 10 billions of events per day is not feasible, right, to analyze. And well, basically we train the algorithm just a couple of days, 1 week, 2 weeks, and after that we start to seeing these kind of results where we can start to hunt. Yep.
Yeah, I'm sorry for the time was
Don't worry.
Do you have anything else that isn't like natural anomaly detection?
Anything else?
Anything that's not network anomaly detection?
Right now, no. That is why we are trying to engage the community in order to find that data scientists that can give us more algorithms or ideas on which algorithms we can use in order to detect more and more, right? Because right now we are using just one. Yeah.
Do you have a forum, or what's the forum for sharing the learned algorithms?
Well, the code is already on the GitHub of the Apache Spot project. You can check there the LDA algorithm there is basically in Spark right now, if I remember correctly. You can execute it over your data, and that is pretty much all. So if you want to contribute or modify something, add or remove things, you can, basically go to the Slack channel, be a committer on the project, and we can work with you.
Slack channel?
Yeah. Let me go there. Is slack.apache spot. So you can. Oh. So anything else? No? Thank you very much, guys.